Hi, I'm Mark Runge. Welcome to the Hartzell Service Center. I'm an aircraft maintenance technician here, and along with maintaining our corporate aircraft, I work with customers who come to the service center for propeller maintenance. Today I'm going to show you how to inspect, maintain, and service a constant speed propeller. At Hartzell Propeller, we are strongly committed to educating technical personnel in issues that affect propeller performance and safety. Keep in mind, this video is not meant to be a replacement or substitute for our manuals. It is an additional source of information to be used as a general guideline. You can also find information on how to maintain metal propellers in the FAA Advisory Circulars AC 20-37D Aircraft Metal Propeller Maintenance and AC 4313 Aircraft Inspection, Repair, and Alterations. Our message to you is this. First, propellers are engineered, tested, and certified against rigorous FAA criteria, but they have the best chance of operating safely and reliably when they are properly maintained. Corrosion, abrasion, and general wear can eventually cause a propeller to fail. Second, it is important that you know how to do an annual inspection on a propeller. Annual inspections and overhauls are critical to propeller service life. And finally, we need your help to get this message across to the aircraft owner. Hopefully, after watching this video, you will have a better understanding of what it takes to do a good propeller annual inspection and why propeller overhauls are a necessary part of maintaining an aircraft. And remember, if you ever have any questions or are in doubt, don't hesitate to call either your local prop shop or Hartzell Propeller. We have a plane scheduled to get some work done, so we'll have a good opportunity to go over these items I want to talk about. Hi Sam, I see you got your cup of coffee.
Yeah, Mark. I made this appointment today because I haven't really done anything to my prop for a while, and I figured it was time I had it looked at.
Okay, have you been having any problems?
No, not really. But I read an article the other day about a guy who had a tip failure and almost lost the aircraft. The article said that by the time he got the aircraft down, the radios had jumped out of their trays and that there is severe engine mount damage.
Well, pilots are usually up to speed about their engine, whether it'll make it to TBO. But sometimes they don't think about the consequences of neglecting their propeller. You should maintain the propeller just like you do the engine. Make sure you maintain it properly, do a good annual inspection per the FARs, and follow the TBO guidelines. Since the propeller hasn't been worked on in a while, it would be best if I followed the guidelines they use to do an annual inspection. I'll do a general inspection of the prop, clean it, do a more detailed inspection. I'll dress out repairable damage to the blades and service the hub. Once that is complete, I'll do a run-up check. Do you have any questions?
No, I don't think so. I'll be back a little bit later to pick it up.
Sounds great. Are the logbooks in the plane?
Oh, thanks for reminding me. The logbooks are in the baggage compartment. See you later.
Before I begin to work on a prop, I look at the general overall condition of the propeller. Things I look for include damage to the spinner, whether the spinner is touching the blade or not, any obvious grease leaks, and the condition of the blades. After I look over the prop, I go ahead and remove the spinner. The 4 maintenance issues we will be covering are inspecting, cleaning and servicing the propeller, blade repairs, and the importance of dynamic balancing. Now let's begin a detailed inspection of the prop. The problems we will look for are corrosion, loose blades, nicks, blade damage, erosion, grease and oil leaks, cracks, and loose or missing hardware. One of the first things I look for is corrosion. Light corrosion on the blades or counterweights can be dressed out using emery cloth followed by crocus cloth to eliminate any evidence of the repair. The hub should also be checked for signs of corrosion. If you find any corrosion on the hub or have questions about the amount of corrosion you find on the blades, contact Hartzell Propeller or an authorized propeller repair station. Next, I check for loose blades. There are 4 different movements we look for: fore and aft play, in and out play, end play, and radial play. First, fore and aft play is forward and backward movement of the blade in the hub. You can check this by taking the tip of the blade between your forefinger and thumb and try to move the blade toward or away from the plane. Slight movement is acceptable if the blade returns to its original position when released. In and out play is movement of the blade toward or away from the hub. This can be checked by taking hold of the blade with one hand and pushing or pulling the blade to or away from the center of the hub. There should be no in or out play. Blade end play is lateral movement of the blade in the hub. You can check for end play by taking hold of the tip of the blade with one hand and trying to move the blade in a lateral direction in the hub. Once again, slight movement is acceptable as long as the blade returns to its original position when released. Finally, radial play is essentially pitch change movement. Acceptable movement is plus or minus 5/10 of a degree measured at a reference station. Now I check the blades for nicks or other signs of damage. Nicks are a common type of damage found on propellers, especially those operating out of unimproved strips. You can see here that there is a nick on the lead edge of this blade. We'll return to this in a moment and show how to repair this type of damage. Blade damage can include erosion of the blade surface. When paint is removed like this, it opens up the possibility of corrosion. Grease and oil leaks are another area of concern when caring for a propeller. Leakage can be an indicator of a serious problem, such as the hub being cracked or a minor problem such as a seal being damaged and needing replaced. A small amount of leakage is common on new or freshly overhauled propellers for about 10 hours or so. I want to point out here that the only type of repair to address an oil or grease leak that can be done in the field is the removal and replacement of the O-ring seal between the engine and propeller flange. A certified propeller repair station should do all other leakage repairs. It is also important to do a visual inspection for cracks in the hub. Give some extra attention to the blade retention area right around here. Cracks may be readily visible or may be indicated by grease leaking from a particular area. For example, you may see a grease stain in this area and can't tell where it is coming from. Before wiping the grease away, mark the area and then inspect it closely. After removing the stain, the grease may have seeped through a crack and made the stain. Another indication of a crack is sudden vibration. This should be a red flag, so listen to what the pilot tells you. It is very important for you to understand that if cracks are suspected, additional inspections must be done at an approved propeller repair station before further flight. As basic as it sounds, one last thing you want to check for is loose and missing hardware. This can include anything from missing lubricaps to broken safety wire and checking torque values. Well, we've talked about the main inspection points to be concerned about, and now it's time to clean the propeller. Cleaning the propeller is a straightforward process, and there are just a couple of points to keep in mind. First, do not use pressure washing equipment on the prop. There is a chance that water will be forced into the hub, leading to a corrosion problem. You want to remove any grease or oil by wiping the area with a cloth soaked in Stoddard solvent. Next, you want to wash the propeller with soap and water. You can either dry it with a towel or let it air dry. If the spinner needs attention, we recommend polishing it with an automotive type aluminum polish. Now, let's go back to that nick we found and do the repair. It is very important to know the proper techniques to dress out a nick in the blade. Nicks and gouges need to be dressed out to prevent stress risers. Stress risers can lead to cracks and failures. There are some general rules of thumb to follow depending on where the damage is. If the damage is on the leading or trail edge, you measure the depth of the damage and multiply this number by 10. In other words, you rework the area surrounding the damage 10 times the depth of the damage. If the damage is on the face or camber side, measure the depth of the damage and multiply this number by 20. Again, you will rework the area surrounding the damage 20 times the depth of the damage. Keep in mind that all blades have limits regarding their thickness, width, and length. After repair is done, the blade must still meet the required dimensional limit at a reference point on the blade. If you have a question as to what the limits are for a blade or whether a blade is repairable or not, call Hartzell or your local prop shop. To begin, you file or sand the damaged area to the dimensions we just described. The damage we are working on is 65 thousandths deep on the leading edge. Therefore, I will multiply that number by 10 and work the area accordingly. Once the area is worked out, I then polish it with emery cloth and then crocus cloth to remove any traces of filing. Next, I inspect the area with a 10 power magnifying glass and do a dye penetrant inspection to ensure that no surface defects such as cracks or file marks remain in the repaired area. I now wipe the blade with a cleaning agent such as MEK to remove any residue. Before we leave the topic of blade repair, I want to talk about repairing erosion damage. Erosion damage is typically very similar on all the blades in a propeller assembly. However, if one blade has more extensive damage, all of the blades should be sanded to replicate the repair of the most severely damaged blade. This practice is important to maintaining the balance after refinishing. The next step is critical. We cannot overemphasize the importance of treating the repaired areas to prevent corrosion. This is done by applying corrosion preventative to bare aluminum surface. Oakite 31, Chromacoat L25, or Aladine 1201 are approved coatings. Once the corrosion preventative is applied per the manufacturer's instructions, we can apply the appropriate finish. The correct paint for a propeller can be found in the propeller owner's manual. There are a few more areas of propeller damage I want to mention. First is a foreign object strike. A foreign object strike can include anything from a small stone to a severe ground impact. It is important to take a conservative approach because there is a possibility of hidden damage. If a propeller sustains a foreign object strike, you need to inspect before further flight. You must overhaul the propeller if you find a loose blade, noticeable or suspected damage to pitch change mechanism, a bent blade, any blade diameter reduction, a bent, cracked, or failed engine shaft, or vibration during operation. If you find any of these conditions, or you suspect any of these conditions, send the prop to a propeller repair facility for a more thorough inspection. If you have a prop with a bent blade, do not straighten the blade before sending it to a prop shop. If a propeller repair station finds evidence of an attempt to straighten a bent blade, they have no way to judge the severity of the strike. Therefore, they will assume it was severe and the hub and blade will be scrapped. Let's say that a customer comes to you and says he thinks he took a lightning strike on the prop. Then an inspection is required before flight. This inspection includes a visual inspection of the propeller, spinner, and if installed, the de-ice system. The propeller can be operated for an additional 10 hours if this inspection shows that the propeller is not severely damaged and meets the requirements found in the appropriate Hartzell manuals. Unless you have access to the overhaul manuals for the blades and the standard practices manual, you will need to contact your prop shop or Hartzell product support. The important thing to remember is that regardless of the temporary inspection results, the propeller must be torn down and inspected before being returned to full service. The damage we are concerned about includes possible arcing of the parts or superheating of the components. Both of these could lead to failure. I want to briefly mention overspeed to make you aware of what it is. Overspeed occurs when the propeller RPM exceeds the maximum RPM stated in the aircraft type certificate data sheet. The total time at overspeed for a single event determines the corrective action that must be taken to ensure that no damage to the propeller has occurred. Hartzell Propeller recommends that the tachometer be calibrated every annual. If the tach is reading incorrectly, the pilot could inadvertently be overspeeding the prop and not know it. If the propeller is placarded against operating in certain ranges, the pilot could be running the prop in this range and again not know it. Let me show you a graph for the reciprocating engine overspeed limits to help you better understand what I mean. This is a graph showing reciprocating engine overspeed limits. You can see that if a prop overspeeds at 105% for 20 seconds, no corrective action is required. However, if a prop overspeeds at 114% for 20 seconds, a search inspection is required. Taking it another step further, 116% for 20 seconds requires an overhaul, and 121% for 20 seconds retires the propeller. During overspeed, we are not only concerned about the additional centrifugal forces that are generated, but some applications have sharp increases in vibratory loads at RPMs above the maximum rated for the airframe engine propeller combination. Propeller failures are normally the result of fatigue and are usually attributed to one of the following: corrosion that has gone untreated, nicks that were not dressed out or dressed out improperly, previous history of ground or foreign object strikes, operation in a placarded range or outside of the certified operating range. The inspections that I have talked about earlier may seem like common sense, and they are, but they must be performed properly and on a regular basis, per the appropriate manual. The NTSB files are full of accounts of propeller failures from corrosion, damage, or simple neglect. Some of these failures resulted in fatalities. A failed propeller may even have been on an aircraft that just came out of annual. This leads us to believe that there are aircraft with annuals signed off when there is corrosion or damage evident on the propeller. The failure of a propeller may have more dire consequences than an engine failure. If an engine fails, the pilot may have the option of gliding an aircraft to a landing spot. However, if a prop fails and throws a blade, the vibration loads placed on the aircraft can rip the engine from its mounts, rendering the aircraft uncontrollable. You need to remember that the propeller is the most highly loaded yet most often neglected component of the aircraft. This is why the inspections we have been discussing are so important. Okay, we have finished cleaning and inspecting the propeller and made some minor repairs to the blade. Now we are ready to go ahead and service the propeller. The first thing we do is lubricate the hub. It is important that you check the appropriate manufacturer's manual to see what type of lubrication the propeller you are working on requires. This particular Hartzell model requires grease and should be greased every 100 hours or 12 months. If the propeller is brand new, you should grease it after 1 or 2 hours. This is because the centrifugal force will pack and redistribute the initial grease. Aeroshell 6 is the recommended grease in most Hartzell propellers. On aluminum hubs, each blade socket has 2 grease fittings. Remove the Zerk fittings from the side of the hub that corresponds to the blade trailing edge. Take a piece of safety wire and make sure the opening is clear. Using a manual grease gun, insert 1 ounce of grease into the Zerk fitting or until grease comes out the opening where the fitting was removed. 1 ounce of grease is about 6 pumps with a manual grease gun. It is important not to put excessive grease into the hub. If too much grease is forced into the hub, grease can be pushed into the center of the hub. This can cause an imbalanced condition and seal leakage problems. You should be aware that on older style aluminum hubs, the Zerk fittings are not located on the hub parting line. If you are servicing one of these hubs, you will need to remove the Zerk fitting from the engine side of the hub. Insert the grease into the Zerk fitting on the cylinder side of the hub. We are now ready to replace the Zerk fittings. We want to torque them per the owner's manual and replace the lubricaps. Hartzell steel hub propellers are a little different. Each blade clamp has two Zerk fittings. Remove one of them from each clamp and again use wire to make sure the opening is clear. Then use a manual grease gun. Insert grease until grease comes out the open hole. On steel hubs, we don't have to worry about grease being pushed into the center of the hub. I should mention here that very old propellers had clamps with only one Zerk fitting. Should you come across one of these, loosen the Zerk without removing it entirely. Pump grease in until you see it come out around the threads of the Zerk fitting. If you are working on a propeller that uses an air charge, the air pressure needs to be checked per the manufacturer's manual. For example, this Hartzell model is checked every 100 hours or once a month, whichever comes first. The correct pressure should be listed on a label located either on the cylinder or the flat portion of the spinner under the removable spinner cap. If you cannot find the label, refer to the owner's manual for the correct pressure. If the pressure is low, nitrogen is a preferred charging medium. An operational run-up of the engine propeller is recommended any time the propeller is removed or significant propeller maintenance is performed. But before we demonstrate the run-up, I want to mention the importance of dynamic balancing a propeller. As you know, all props are statically balanced when they are new, overhauled, or had a major repair done. Dynamic balancing balances the propeller to the engine and helps reduce vibrations that can be caused by a rotating system. Dynamic balancing can also help prolong the life of the propeller, engine, airframe, and avionics. Dynamic balancing is only recommended, not required unless specified by the airframe or engine manufacturer. I'm going to go over just a few basic things about dynamic balancing. First, there should not be more than 0.9 ounces of weight in any one location. It is preferable to mount the weights on the spinner bulkhead. Many turbine bulkheads have factory-installed self-locking nut plates for this purpose. A propeller should be balanced to 0.2 IPS or lower. If this is not possible, the static balance needs to be checked. The propeller owner's manual will have more specific information on dynamic balancing. An operational static RPM check should be performed after installation, maintenance, or propeller adjustment. A calibrated tachometer must be used to ensure the accuracy of the RPM check. You can check the accuracy of the tach at various RPM settings by using a device such as Hartzell's View-Through 2 tachometer. First, back the governor maximum RPM stop out one turn. This is done to make sure you are getting propeller RPM and not governor controlled RPM. Next, advance the propeller control lever to maximum RPM, then retard the control lever 1 inch. Make sure the brakes are set and the wheels are chalked. Start the engine. Slowly advance the throttle to maximum manifold pressure. Slowly advance the propeller control lever until the engine speed stabilizes. Depending on the installation, if the engine speed stabilizes at the rated RPM to 50 RPM lower than the rated RPM, the low pitch stop is set correctly. If the engine speed stabilizes above or below the rated RPM, the low pitch stop requires adjustment. Should this be the case, you should refer to the owner's manual for the proper procedures to make this adjustment. Shut down the engine, return the governor maximum RPM stop to its original position. Remove the spinner, check for oil and grease leakage. When you are satisfied everything looks okay, reinstall the spinner. Well, I hope you have enjoyed the time we have had together and were able to learn something new. Before Sam shows up, let me review a few major points. When you inspect the propeller, you want to look for corrosion, loose blades, nicks, grease, and oil leaks, cracks, and loose or missing hardware. Remember, grease or oil leaks can be an indication of a crack. Inspect thoroughly before wiping off the indications. When you clean the prop, do not use a pressure washer. Simply wipe it with a cloth with solvent and wash with soap and water. If you need to do a minor repair to the blade, make sure you use a corrosion preventative along with paint when refinishing the repaired area. Keep in mind that in addition to the bending and vibrating loads that the propeller is encountering, there are 10 to 20 tons of centrifugal force trying to pull the blades from the hub during operation. You can see why it is so important to make sure that the prop is in good shape. A prop that is maintained helps ensure the safety of passengers and the aircraft. Just like most other mechanical parts, the propeller can show signs of impending problems or failure. Watch for them and correct them immediately. If you come across a problem that you are unsure of or don't understand, call us at Hartzell or your local prop shop. Remember, your customers believe what you say to be correct. If you give the aircraft owner the impression that propellers don't need maintenance or to be overhauled, you are doing a big disservice to your customer and your profession. One more thing. Most of what we covered today is in the propeller owner's manual. Tell your customers to keep this manual with their aircraft logbooks and refer to it often. Hi Sam, did you find your way around okay?
Yeah, fine. And thanks for use of the car. Did you find anything?
Well, let me show you what I did. I cleaned and serviced it per the manual and didn't find any loose blades or evidence of oil or grease leakage. There was a small nick on the blade that I dressed out and refinished. I also did a static run-up and found the low pitch stop to be set okay. And let me show you the logbooks. I entered the proper entries here in the propeller log, along with the tack time and per the FARs. I also checked to make sure that all ADs were complied with and noted what manufacturer's service documents apply to this propeller.
That sounds great. Am I ready to go? I've already taken care of the paperwork in the office.
There's one more thing I want to remind you about. You mentioned earlier you hadn't done anything to the propeller recently. Service Letter 61 addresses the recommended overhaul periods for the propeller. While reviewing your logbooks, I found that your prop is overdue for an overhaul. I know you fly under Part 91, but as your mechanic, I strongly recommend that you follow the guidelines set in the service letter and get the overhaul done.
Okay, makes sense to me. I've been thinking about what we talked about when I first got here. Do you have a copy of Service Letter 61, or can you tell me where to find it?
You can get the service letter off the Hartzell website at www.hartzellprop.com. There's also a lot of other useful information about propellers you might find helpful, or call our product support department and they will be glad to get the information. Oh, and remember to keep your owner's manual with the logs. If you do have a question about the prop, you can probably find the answer in the manual.
Thanks a lot, Mark. I better get going.
All right, let me know if you have any problems, and thanks for coming in. Have a safe flight home.
All right.